Hi everyone, today in Integrated Math 1, we're going to go over Chapter 7, Lesson 5. Here are the objectives. Make sure you write them down in your notes. Exponential functions. An exponential function is a function that can be described by an equation in the form of y is equal to a times b to the power of x, where a cannot equal 0, b must be greater than 0, and b cannot equal 0. So that's what this symbol means, cannot equal. All right, so we have two different types of exponential functions. We have exponential growth functions and exponential decay functions. So notice we have this formula. Notice we have these two different functions. They are both the same, but the main difference is our b's. If it's going to be a growth, b must be greater than 1. However, if it's going to be a decay, 0 is less than b, and also b is less than 1. And a is still going to remain the same. A always has to be greater than 0. All right, so let's look at our graphs. So we have the equation and our conditions up top here. Domain and range, in this case, is all real numbers. So as you can see, there's no limit to these. So that's why it's going to be all real numbers. The intercepts, we have one y-intercept. It's only going to cross the y-axis one time. And in this case, it's never going to cross the x-axis. So no x-intercepts. It's going to get closer and closer, but just get close to it. And the end behavior, as x increases, f of x and increases, but also remember f of x is equal to y. And then as x decreases, f of x approaches 0. However, with the exponential decay function, we're still going to have, in this case, for our picture of our graph, we have all real numbers. And we have one y-intercept, which is here, and no x-intercepts. The end behavior is as x increases, f of x approaches 0, which is what we see here. And as x decreases, f of x increases. And you can also see in the graph, the growth is going up, the decay is going down from left to right. All right, so let's try example 8. Graph y is equal to 3 to the power of x plus 6. We want to find the y-intercept and state the domain and range. So first of all, we need to find our x's and y values so that we can graph this. So I'm going to say x, y is equal to 3 to the power of x plus 6, and then I'm going to say y. So I'm going to make a little chart here. So I'm going to choose some random numbers, some positives and negatives. So negative 3. So we have 3 to the negative 3 power plus 6. And remember, when we have a negative power, I'm going to do this on the side, on the bottom. 3 to negative 3, in this case, would be 1 to the 3 to the positive third power. It flips and becomes a positive exponent. So this, in our case here, is 1 divided by 27. So 1/27th. Plus 6 will give us our y. In that case, it's going to be a decimal, 6.04. And then we have negative 2. And these ones you'll be using your calculator to help you figure these out. And let's say we choose negative 1. So we just want to get a general idea of what's going to happen with the graph. So we have to pick some positives and negatives. So as you see, I'm getting closer to 0, and then I'll choose a positive 1 as well to make sure I see how the graph is. And I went 0 because remember, I want to find the y-intercept. To find the y-intercept, you need 0 as your x value and b, which is your y-intercept. So x must be 0, and we will find out what the y-intercept is. Just a reminder, 3 to the 0 power, or anything to the 0 power, is 1. So we have 1 plus 6, which is 7. So 3 plus 6 is 9. All right, so then when we go ahead and graph this, this is what it's going to look like. So each of these points are already plotted here, but we haven't actually found everything we need. First thing we want to do is the y-intercept. State what it is, 0, 7. So check, and state the domain and range. So the domain, remember, is your x values. There's no limit to these, so it's going to be all real numbers. Our range, our y values that we're going to be looking at, well, it's going to be that it is y is greater than 6. Because it starts at 6 here, and you can see it just keeps on increasing. And there we go.